This is page 108 of your math journal. We're going to call this one mean absolute deviation. Okay, now mean absolute deviation. Let's write the definition. Mean absolute deviation is just the average distance I don't know, I wrote a G. The average distance from the mean. Okay, a couple steps here to find it. So first, you have to find the mean. After that, second, find the distance of each number in the data set. From the mean. And third, find the mean of the differences. Alright, so let's do this example. Okay, example, let's say we have this data set. 3, 7, 6, 8, 4, 9, 3, 11, 6. What I want you to do is I want you to make a table. And I want it to be 3 rows. Okay, so this one I want to be your data. This I want to be your distance. And then this bottom one, I want you to split into 4 pieces. So we have data and distance. And then I want you to write mean. And then I want mean absolute deviation. And just remember, this makes you mad, M-A-D. Alright, so how to find it? First of all, we need our data. Let's put these in order from least to greatest. So it looks like we have a 3. And another 3. So I've used those. Next would be 4, 6, another 6, 7, 8, 9, and 11. Alright, so let's find our mean. We're going to add them all up. So we'll do Sorry, we're going to add one more on there. Let's say you also had 13. So let's put a 13 on here. Okay, so we've used up all those numbers. So we're going to add 3 plus 3 plus 4 plus 6 plus 6 plus 7 plus 8 plus 9 plus 11 plus 13. And when we add all that together, we get 70. Now that we've got 70, let's count how many we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So divide by 10, and we get a mean of 7. So my mean is 7. That's my average number. Now for mean absolute deviation, now we've got to figure out how far every number is from 7. So 3 from 7, that's a distance of 4. Remember, distance is positive. Okay, how far is 3? This is 4 away. 4 is 3 away from 7. 6 is 1 away. 6 is 1 away. 7 is 0. 8 is 1 away. 9 is 2 away. 11 is 4 units away. And 13 is 6 units away. So we found all the distances. So this right here was the data. Now this is the distance. We have to find the mean of the distances. So we're going to add up our distances. So we have 4 plus 4 plus 3 plus 1 plus 1 plus 0 plus 1 plus 2 plus 4 plus 6. And that gives us 27, and then we have 10 distances, so I'm going to divide that by 10, and that gives me 2.7. So my mean absolute deviation is 2.7. That means that our average distance from the mean, so the average distance each number is from the center, is about 2.7 units. Okay, we're going to do one more example. Let's say we have 13, 18, 24, 16, and 27. Okay, so first let's do our data in our table. Let's organize it from least to greatest. And then our distance. This one doesn't need to be so big because we only have 5 numbers. So smallest number would be 13, then 16, then 18, then 24, then 27. Okay, I have to have my mean before I can find my distance. So down here, mean. So we're going to add 13 plus 16 plus 18 plus 24 plus 27. That's going to give us 98. And now for the mean, I need to divide 98 by 5. 98 divided by 5 is 19.6. Okay, so now I need to find the distance. And here is where I'd let you use a calculator, but I need to find the difference. So because 19.6 is bigger than 13, I do 19.6 minus 13. And that would give me 6.6. 19.6 minus 16 would be 3.6. 19.6 minus 18 would be 1.6. Now here 24 is larger, so I do 24 minus 19.6. That gives me 4.4. And 27 minus 19.6 gives me 7.4. Okay, now I have all the distances from the mean. So I'm going to add up my distances and divide by 5. So we have 6.6 plus 3.6 plus 1.6 plus 4.4 plus 7.4. That's going to give us 23.6. Divide that by 5. And we get 4.72. So our mean absolute deviation, or MAD, is 4.72. What does that mean? It means that the average distance of each number is about 4.72 units away from the mean. Now, how would we use this? If we were comparing two data sets, the one that has the larger mean absolute deviation is more spread out than the other numbers.